Hello everyone, welcome to the stream. Today we will continue our work on the Pmod for the Icebreaker to connect SNES and NES gamepads, as well as getting audio out of the Icebreaker. So this Pmod is something we worked on in the previous episode, so check it out if you missed that. There is some additional detail about the design. And this is what we are working with. So this is the Icebreaker, and the Icebreaker has an HDMI dual Pmod connected to it. And if you see here, the Icebreaker has a pre-wired, which is over this legs. It has this Pmod connected with LEDs and buttons, but you can break it off, and you have one additional Pmod here. So you can connect and something else than the what I call head, because it looks like a robot, right? It's like poor robot gets its head lobbed off if you want to use that Pmod. And we then can connect these guys here. So these are SNES gamepads. There's also NES. So Nintendo Entertainment System and Super Nintendo are these two different gamepads. And the cool thing about them is that they use a very simple protocol. So this is just a shift register that you can latch and then shift out. And this way we can write very simple Verilog or simple logic to actually clock it out into our chip. And it is the same thing as retro consoles, and there are some retro consoles already ported to the Icebreaker, like the NES, for example, or Game Boy. And there are some people working on their own invented retro-inspired game consoles that work on the Icebreaker, which is very cool. Just using a RISC-V CPU core instead of something else, which is taking modern open source solutions instead of a Z80 or something similar. You put a RISC-V core in there, and then you create your own peripherals or your own PPU or pixel processing unit, as it was called back in the day, and put that together and make something really cool. Yeah, so anyways, this is what we were working on in the last stream. I did some little cleanup here. So the main thing is we have 4 gamepads that can be connected. So we have, if I look, let's look here just really quick how the pinout is. SNES, this is the pinout. Let's see, I'm a little bit lost here. Just give me a second. So there should be a schematic of an internal of a SNES. I just wanted to show that really quick. Let's do this. I was searching for a lot of stuff. Let's do that. Yeah, so that's one I found in the past, which is not bad. So essentially you have this shift registers, and all you do is latch and shift. Come on, why is it not opening? Come on, Google. You can open it. Usually you are so eager to show me stuff. But yeah, anyways, so yeah. We have those shift registers, and all we need is getting the data out of the device. So we have 2 outputs, which is clock and latch. So we can latch the data in the shift register and clock it out, and it will come out on one of the data pins. And because we want to be able to play up to 4-player games, we have 4 data pins coming in. And this is what is occupying the first 6 pins of the Pmod. And then we have 2 pins left. Hi, Paul. Welcome. we have two audio pins left, so we have right and left, and we can do PWM or PDM modulation. And what we did is we connected an inverter and a buffer, which was a suggestion from Sylvain, to essentially improve the signal strength or like impedance over the three. Anyways, this is all with a lot of asterisks attached, and let's not get into too many asterisks at the moment. But you have the audio that comes in with a buffer, and then it is also being output with an inverted buffer, and then it goes through a high-pass filter. So this goes through a low pass. So you have, this is what you would normally do. You will just do PWM, low pass it, and output it to a line out or whatever a device or headphones. Headphones will be very quiet with this, but that's a separate story. And what we want to do is have a better filter. So a filter has a roll-off. So it is not just cut off at like ideally at a certain frequency if you have an RC filter. But if you add additional stages to the RC filter, you can make a multipole filter, which will essentially make the frequency cutoff steeper. And you can either do additional resistor and capacitor, or use this trick, which does a same thing, actually, mathematically the same thing. Sylvain actually looked it up and made the math for it. So it behaves like a two-pole RC filter, but it will very likely have lower impedance. So it will not be as, it will be stronger drive. The resistor should be 1K when using that circuit. Okay, so we should change these from 3.3 to 1K. Is the capacitance correct, the 4.7 nano? Is that still correct? So yeah, I know that Sylvain did some math to calculate the resistors. Okay, so that's fine. So we will fix that while we are at it. And Sylvain did the math. Let's just copy his numbers. Like, let me copy Sylvain's notes. So yeah, 1K, 1K. So my assumption is the previous numbers we were using, I was copying something from a circuit. Whichever you want, the RC changes. Should I change both of them to 1K or only one of them to 1K? That's the question here. It's like, as far as I understood, I should change both of them to the same value, but I might have misunderstood you. Yeah, both. Okay, cool. Yeah, the ratio has to be correct. So I could change the capacitor versus the resistor, but the ratio is the important thing, obviously. If you have a higher resistance here for this capacitor, it will essentially move the filter to a lower frequency, so make the filter be stronger low pass filter. And because I bet this was set to 3.3 k ohms because of the roll-off, and actually to move the slope further so that you get a little bit better filtered PWM. If you use a one-pole filter. But the problem is the slope. So because we are using this trick here, we can decrease the resistance. So add more higher frequencies, because the roll-off will be steeper. So we will have the filter be a sharper filter. And this is what we are doing here. Yeah, for the power supply of the drives, we have a ferrite and a capacitor to also clean up a little bit the power supply, which is nice. And then we also AC couple the output of our audio to the audio jack, because yeah, if you have a DC bias, so you want the signal that comes out on the audio pin to be essentially going above and below your virtual ground, so it's essentially swing freely and not have a DC bias, so it's essentially have power going through it on average, and you only want to have the swing go up and down. So that's the idea here. You want it to move by both ways. So if you have a electromagnet in the speaker, if you think about this, you want it to go through the 0 point, to swing through, instead of being pushed to one side and just swing on one side of the motion. So having an AC coupling here is a very good idea. Again, audio is even bigger dark art for me than the rest of the electronics. So take what I say a little bit with a grain of salt, or maybe a spoon. But yeah, this is how I understand it, and you're welcome to correct me if I say something stupid. I'm here to learn as much as you are here. Anyways, so that is the audio circuit, and I think we are pretty happy with it. And the other thing I changed, if you remember from in the last stream, I had 4 connectors for the gamepads here, but I decided to put it on one connector. So the connector looks like this. If we switch over to the design, we have this connector here, and we will have, that is up to you, Paul. It's a FPGA, so the frequency you will set yourself. It really depends. It depends on the design in the FPGA. It's a double, no, this behaves as a double pole filter, this circuit that we have here, Paul. This is actually a 2-pole filter. This behaves like a 2-pole. That's what I was trying to explain the whole time. It's like, that's the difference here. You can have a 2-pole RC filter, or you can have this circuit that behaves like a 2-pole filter. It will be PDM, not PWM, yeah. So PDM, and yeah, and because it is, I'm pretty sure we can drive it pretty high. Yeah, like 20 megahertz or something. That should be totally doable on this chip. Yeah, anyways, it really depends on the design that we put here in the FPGA, and that is completely up to the designer of the chip itself. It's like, this is the advantage of having an FPGA, Paul, right? And a microcontroller will have some output, some PWM output, some hard IP that you cannot move, you cannot change. It is the way it is, and it will have the frequency that you have. End of story. On the FPGA, you are constrained essentially what the fabric speed is. So it's, in this case, considering how the other parts of the NES are, we already are driving the video at 20 megahertz, so we probably can do the audio at 20 megahertz or even higher, probably. In theory, the IOs can go up to 100 megahertz. So it really is a question of how we design the HDL. So it's not a microcontroller, so it's nice. So we are not as constrained. Cool. Anyways. So I was thinking that because I wanted to be able to connect multiple ways to the Pmod, I either want to be able to use the depends on the connectors. So these are the SNES connectors. Then one thing I promised you to show you is my wonderful collection of, these are my connector collection. So this is the Molex SL series connectors that I really like. The cool thing about them is, let's see if I have the two corresponding parts. So they can be wire to wire or wire to board. And if let's go on desktop here. So this is these are the SL connectors. You can crimp them. I have a crimper for it, and they have this wonderful clip, and they clip in. I really like those. They are just 0.1 inch pin headers, so you can either do this, or if you want a breadboard, these are also SL crimps that I just like crimping, and then I heat shrink, and then I have a board-to-board connector. Or I can have a connector like this. And so I was thinking, because these cheapo, crappy gamepads that I get from Adafruit, I usually lob off the connector on this because I want to connect it to the PCB or the breadboard. Rafa Twitch, right? That's the name. Welcome to the stream. Thank you for the follow. Yeah, Rufatwitch. Nice. Welcome. And so I will basically just put these connectors on here. Obviously the 5-pin version of this, not the 4-pin. And on the PCB, I wanted to have the corresponding through-hole connectors. No Zero, welcome to the stream. Thank you for the follow. And so that would be 2. And 3 would be NES, which is, again, another connector. If you look at this is another connector. So instead of making 3 Pmods with different connectors, or trying to like shoehorn this stuff together, I decided to make pods. So pods is a term from a logic analyzer world. This is where you get devices like these. So this is a pod for a logic analyzer. So this connects to your logic analyzer, and then you get a pod that has connections on here that then you fly wire to something else. Might even have one of the cables, or even this. Yeah, this is another pod design. So this is logic analyzer world. So I thought it would be nice to do the same thing here. So I spent yesterday just creating pods. Yeah, that was fun. So I created 2 so far. So I want an NES SL. So the SL is the first one I created. So it essentially has the IDC 2-row connector that goes to single connectors. And this is how this looks. And you have 4 SL connectors, a little bit routing. It's pretty large. It's like I'm like, oh, now I have to. I am getting into the world of others where they are like, oh, my OshPark orders are so expensive. It's like, yeah, if you have just massive connectors that take up a lot of space on a PCB, then the boards are starting to just explode in size. And I'm like, that's why I usually try to make everything small so that the PCBs are not so expensive. But yeah, I will make this. So let's see, so this is the 3D rendering, and you get 4 connectors, you get the IDC ribbon cable going to the pod, and then you can connect to it. I just, for good measure, I added some capacitors here, just for the fun of it. Yeah. Let's see, what are you guys talking about there? Why does PDM have better noise shaping? Oh, interesting. Pwm switching frequency is basically your clock. And PDM switching frequencies is pretty much your clock. So no, the first one is PWM. Okay. Oh, yeah. So the frequency of PWM is clock divided by 2 to the bit amount. Yes. So you have the fundamental frequency of your, essentially your carrier is much higher in PDM than it is in PWM, because in PWM you just go up and stay up for a certain period of time, then go down, and then you try it again. So you go, the whole cycle of the wave is as long as the period dictated by the register value, essentially. And PDM, it really depends. Like if you are, for example, 50%, then you have 50%. Half of the bits are on, half of the bits you have like a get a comm at the full frequency of your carrier, of your clock that is being driven. So yeah, you drive the frequency that is the artifact of creating the waveform higher, and especially the lower the output value, or like the average value, the higher the frequency will be. And it will be for up until I think half of the output value, you will get the maximum frequency, and then it will start dropping off. Anyways, that's roughly how I understand PDM versus PWM. All right, so we have this pod, and then I did a second pod. So the biggest problem with making this was actually the fact that KiCad doesn't have a footprint for this specific connector. They do have the vertical version of the connector. Someone's contributed it. What is the square with the null in it? It's a placeholder for the logo, for the 1-bit squared logo. I don't push my boards to the public with my logo in it. For reasons. It's essentially I do this as a marker when people are lazy. Well, so in general, I love it when the community and the people in the community take the boards that I design, make the changes to them, or not even changes, and make it for their own purposes and their own use, and help developing it, and like contribute and are part of the community. It's like anyone who is here in the chat, I'm pretty sure, is that kind of a person. It's like, you are interested in this stuff, and it's like, go ahead, go on the repository, take my design and send it to Oshpark, order a few boards, make it. I love that. This is great. But what I'm not a fan of is well, the companies that are making a business out of taking what people publish and just make it at a very thin margin and sell it en masse on online stores like eBay or AliExpress. It is I have to make a living out of this. It's like, either I do this and share it with all of you and work with you and can be helpful, and we work as a community, or I don't, and I can't do this unless I can make a living out of this. So if people want me to continue making these things and sharing these things, don't buy from AliExpress. But if you want to build one for yourself, please do. That's why I'm putting it out there. So these logos are there so that at least we know that if someone buys this stuff, comes to us with like, oh, I want help. It's like, I bought this thing. And I bought this thing, it doesn't work, can you help me out? And it's like, yeah, where did you get it from? Or at least show me a picture of the board. You will see pretty quickly that this is made by them, because these manufacturers don't bother to even think. They just take whatever is online and just print it out. Just quickly print it. And so there will be a null in here. There will be not a 1-bit squared logo in here. So at least we know, and it's like, I will, if this becomes more of a rule where people are coming and asking for support and buying on AliExpress, at least I will try to encourage them to, like, maybe in the future to buy from us instead. I understand that there are people that are really poor, like not even students. I don't think college students, it's like if you can pay for tuition, you can buy a cheap board from me. But if you are like really struggling for money and you want to work on this kind of stuff, you can order it and build it yourself, for example. You will learn more from that. But if you buy from AliExpress, it's like, yeah, to a degree, I can understand that. Yeah, anyone else, it's like you're not helping anyone. So yeah, if you want support, buy the genuine stuff, and at least we will know where it came from. Sorry, again, a rant, and I'm trying to explain it. It's really difficult to like put it in words so that, because it is complicated. It is like financial, like discrimination is a thing, and it makes things complicated because there are genuine reasons why people buy this stuff from AliExpress, and there are other reasons where I find it severely deplorable. It's like you are just a jerk, and you want to save I bought it for $10 instead of $50. It's like there's a good reason why it costs $50. Why this person is charging this much. So yeah. Anyways, sorry about that. I just trying to explain it how it works. All right. Anyways, let's get back to it. So this was half of the day yesterday to get this footprints. Fortunately, on DGKey you can get the 3D models, which was nice. Yeah. Yes. So yeah. let's not keep going on the rant. I have to control myself. All right, so now I also made the SNES version of it. So this is pretty much the same thing, and 3D model. So there we go, and so there are the 2 unpopulated pins that are used by certain controllers, so we will not get access to that. But we will get this. So yeah, so now we have 4 controllers, SNES controllers. So the model was really wonderful. This model was published by this. I have to buy some of those connectors from them as soon as they come back from the quarantine, because I didn't know that they existed. Before, that there is a company making pretty connectors. Where is it? Libraries, I think it's in modules. There's a link to the maker. There we go. Roughnet. So Roughnet, they are making those injection molded connectors. They look very pretty, and they publish. This is the big difference from buying on connectors that you can't buy anywhere else on AliExpress, is that you don't get a datasheet or the dimensions or a footprint or anything. And buying from someone like this, you get a proper datasheet with dimensions and everything. It's glorious. So yeah, I definitely have to buy a bunch of those connectors from them. And they also are so generous that they published a 3D model in step format for it. It's great. So I was able to have a proper rendering of it. And what they also do, they make a 4x SNES box. Where is that? So they are currently closed. They're in Quebec, Canada. As soon as they come back, they say May 4th. I hope I can order some stuff there to say at least a little bit of a thank you for their efforts. Yeah, so anyways, there is a box Let's see if I can find it. I did find it yesterday. Products. Yeah, there we go. So this is a adapter box for USB, so you can connect your SNES stuff to it, and it connects over USB. Oh, that might be even a different product. But anyways, so this is pretty cool, and this is what I was looking for relatively to that. The problem is I can't find the similar thing with the NES connector. FL4 for FL, thank you for your follow. Welcome to the stream. I wish I could find the same thing. I only found, as I said, completely undocumented random connectors on AliExpress to build a pod for this. So I have to order those connectors and measure them because there's no mechanical drawing I can find, and make a pod for NES. But for now, that should be good enough. And we can connect those. The cool thing also about this system is we can have a ribbon cable that has multiple connectors on it and have multiple of the pods connected. So you can have player 1 connected with an SNES controller, player 2 connected with an NES controller, and the third player connected over these connectors. So we can have all three pods connected, as long as you don't have more to the same player connected the game controllers. It will work out. Of course, the cable will be long and the signal will be meh, but I think it is pretty cool. I can IDE drive connection with the ribbons that have multiple IDC connectors on there. Okay, so now let's go back to the core of the fun here, and let's try to lay out this thing. So we have the voltage selector. Oh, one more thing I changed. I realized that the buffer inverter chip, the footprint that I drew during the stream, actually that part is not available on DigiKey. This is the only package format that is not on DigiKey in stock. So I switched it over to the SOT363, I think. Something along those lines. Yeah, SOT363. I switched over back to that. It's fine. It is pretty much the same size as the other package. This is SOT and the other one is QFN. If I was making a bigger quantity of this, I definitely would prefer using the DFN. The DFNs are much easier to handle in production, surprisingly, than the SOT stuff. The SOT stuff I had way more problems with bridging between pins and issues with assembly than with the DFN parts. DFN parts are much less painful. Untuition, thank you for your follow. Welcome to the stream. Yeah, so that is essentially it. And we will, the idea I had is put this guy here and put the audio connector on the end of the board. That's the idea here. And yeah, I should probably move this stuff out. And I should rename these, because this is copied from the LED panel driver Pmod. 100 nano, so that's the input. Yeah, I will have to sort the things a little bit. Oh, right. So we have These are the buffers, right? I will have to go back and forth between the PCB. Oh, Karen, welcome to the stream. Yeah, I'm doing fine, thank you. I hope you're doing well too. How is EMS doing? Are you taking care of things there? I heard you were going to the makerspace and fixing some stuff and maybe etching. So one like completely off-topic thing. So there is a thing called hardware happy hour, so 3H, and several cities have that, and I never really paid much attention to it. I know this existed, but I never attended one of them. I was going to the Dorkbot in Portland, but it's similar thing where you come and you show Leonhardt 19. Thank you for the follow. Welcome. And the nice thing about the happy hour is you just go there and you show off your hardware and the things you're working on. But now, because people cannot meet in person, this moved online. So there is a Discord for hardware happy hour. So 3H. I should find a link for that at some point. But Chicago, so Chris Gamble was moderating the Chicago one that was on Thursday after the stream that we had here. And it was really cool. It's like you have those audio channels in Discord. Side note, we will get video, like face video in Discord next week or something as a feature, which is like, what? That's cool. But yeah, audio is it's completely fine. And we had those tables with smaller groups that we were going to, and it's like hanging out with people and talking about stuff. So that was really nice. And I thought to share that, and you should check it out. There's, I think Phoenix is today, has a hardware happy hour. So you should check it out. And because EMS also, it's like we cannot have the open hack nights. So I was recommending and telling Karen and Ben, who are also on the board of EMS, maybe we should do a Eugene hardware happy hour. So yeah, maybe one of the folks would want to organize that. I don't really have time to do that, but I would definitely drop in and put in my 5 cents. All right. So that's complete off topic, and I'm sorry about that. But I thought you might enjoy this, and I wanted to share that. So yeah, thank you for the share, Karen, there. Alrighty, so let's see. So this is the capacitor on the output. So this is the output, the input one. So yeah, there are 2 per driver. So this should be I think we are missing some more parts here. I think these might be related to. Okay, so yeah, I like organizing this stuff before I start laying it out more carefully. So this should be U3, U2, U1. So this is the first one. This is the second one. This is the third one. Let's do some micromanagement here. Let's start with this one. So that will go here, because this is this one. Yes, correct. This is so much easier if you have 2 monitors. You just put the schematic on one monitor and the layout on the other monitor, and then things just light up. So see, it's like I can click on a part and it focuses it in the PCB layout automatically. So I can say it's like, oh, I want to group these. So I'm selecting this one, that's fine. This one, that's fine. Then I want the 10K that belongs to this this section of the schematic. So that's that, and then I want this capacitor that belongs on the other side, so I can move this. Not that it really matters with the coupling capacitors, I know, but I like to keep things consistent. And on the Blackmagic probe I was doing a structure like this, so I can have something like that. Huh, yeah. Probably like this, because there's no center line. It's like Minecraft, you know? Just aligning things fully OCD-like. Nice arrangements are important. Okay, so that looks good. And then we will just repeat that. Rinse and repeat. Like this, and then we want this capacitor here. Doop doop. And then let's move this one out of the way. This resistor, move. Oh, you're making masks. Nice. Good job. Yeah, I don't have a 3D printer, so JKIV, welcome back. You missed my ranting. So let's see, is that good? I think that's good. There we go. And another one. Let's do this. And this should be pretty obvious that this is this one. So I decided to put these resistors here. So usually you can just tie them to ground or and it was not about I2C. That was from last stream. This stream was more about opportunistic companies making money on open source hardware and not being part of the community, la la la. And why I don't have, why I have the null logos on my boards. Well, I do not have them on the production boards. I have my logo on my production boards. Alrighty, so that is that. Now we can move this. And we have the first set of pins. So this will be something like that. So this is the clock and latch. And then we have the 4 datas. Nice pattern. Patterns are important. Let's see how that works out. I might need to nudge it a little bit more. There we go. So that's data. Yeah, so I didn't want to move, because the alternative would be to put it like this, but then it hangs off the sides and I didn't like that. So I will leave the bucket sitting on the board and then you get a ribbon cable from here. So that's the idea here. I will need to connect some power to this from the TVCC. So I probably will do a flood fill on the back of the board with the TVCC. If you saw, I use 0.1 millimeters usually. And I use 0.2 millimeter traces for just rough stuff, that boring stuff, but in general I use 0.15. This is not set in here, but yeah, 0.15 millimeter trace space is my standard. And then 3 millimeter drill via with 0.5 millimeter, so 0.3 millimeter via with 0.5 millimeter pad. So basically 0.1 millimeter annular ring. Yeah, no worries. Thanks, Jordy. Thanks for asking. These are good questions, of course. And move, maybe we should do it like this. That looks cute. All right, so that's nice and even-ish. I feel like I'm off here. I am off. I'm totally off. So let's move this. There we go. That's correct. Can I just disable the... Oh yeah, they only light up when I move them. That's fine. So the question is, how much space do I need between them? That's I could theoretically... So this is what the courtyards are for. So you can put the parts against each other by having the courtyards essentially like this. So that's the idea. This layer, the courtyard layer, you draw the expanse of where you don't want any other parts in the area, and the design rule checker will actually complain if you have intersecting courtyards. And this is an issue we had the other day when we were playing with the Ice Bitsy or Icebreaker Bitsy, this board. There's several parts on here that are very close together, and I was ignoring the rule and squeezing things in harder than usual. 0.25 drill, 0.5 pad. Yes. Oh yeah, you want a wider annular ring, but you can go with smaller hole. Yeah, that's yeah. There's always variability. Yeah, that's why I have 0.3, 0.1, because I think historically that was PCB card design rules. Because I used to use them until then prototypes, as I said, I'm using Oshpark for prototypes, but for like bigger batch production, Oshpark is not usually not the right choice. So I used PCBWay for a bit, and now I'm using KiCad, and I'm really happy with it. So, apropos, another tangent I can show you. Blackmagic Pro PCBs arrived in this plum color. It's a nice plum color. That's KiCad. It's a very, very light plum. I like the color. Yes, it's KiCad. Yeah, they do a good job. They actually do pay attention to the quality of the boards. They are comparable in price, if you ask me, with PCBWay, but you have the split between setup cost and production cost. So if you order the same board the second time, you don't pay the setup costs, I think, which are the majority of the cost. It's like if for what is it? Yeah, it's I think setup cost is basically flat $200, and the rest is PCBs. But the setup cost is like way more than the boards. So, anyways, let's go back to this and see how much space do I want here. Maybe we should just start routing this. Do I have actually a fill in here? Yes, I do, and this is a ground fill. Yeah. So this is 3.3 volts, so we want the TVCC to be on this side. So we probably would, the alternative would be to flip this around and put the 3. I still don't like it. Doesn't really matter at the end. We still have to go in here, plug in here, and then go up from these. So we need to route. Yeah, we still have plenty of space for this. Yeah, I don't like using JLC PCB. I had too many horrible boards I got from them. They are really dirt cheap, and even like one day prototypes are very dirt cheap, but it's like the quality is atrocious. It's not even that. It's not really the quality is so bad. The quality can be okay. The variability between runs is huge. One day you get one board and you order the same board the second time, and it will have some other different things futzed around in your Gerber files. It's the consistency is the problem with JLC PCB, and it's really annoying when you try to make more than one of a thing and you cannot just drive around the issues that you will get the boards with. Yeah. You can definitely break out the stuff with Oshpark. So Oshpark has the rules online, but you can easily start breaking those rules that are on these are conservative rules, let's call it that way. If you follow the rules on Oshpark website, it's very likely you will get a working board. If you start breaking them, you might get boards that are out of the 3 boards, maybe 1 will not work, maybe 2 will not work, but 1 might work. So you really, what you do, you just change the capability, like break the capabilities or the specs on the Oshpark website and just do it. And it just take the risk that it might not work. I did that a lot, and I still do that, where it's like, oh, I want to break out a 0.5 millimeter pitch BGA. You can do that with Oshpark. You just break a few rules. But it is possible. Yeah, and 0.8 is doable even with 6.6 rules, so yeah. 0.5 not, yes, that's true. But yeah, I've seen people break out 0.5 millimeter pitch BGAs with Oshpark. So it is possible. It is crazy, but it's possible. Cool, all right. How do we do this? I'm still pondering how to do the power supply stuff, but I probably should just create a pour for the power in the back here, and then ground should be fine with the front pour, and I have to, how does this work? So clock, and we can do 0.3 for power, although this will make soldering annoying, so let's not do that. Let's do that, just 0.2. Is this point? Yeah, 2. Yeah, this is how the distance, because I left 1 here and I left 2 here. That should be fine. Oh yeah, this should be. And then I can do 3.3 volts somehow. Yeah, I have to figure out how I do 3.3 volts. Probably on the back, I do a large thing for 3.3 volts, and then like a bus going along. This will be interesting. I'm really curious how it will end up being. Let's do this, just get a little bit of the random stuff out of the way. what's going on here? Why is this not connected to 3.3 volts? That's weird. Oh, what? That's not great. It's not connected to 3.3 volts here. Yeah, at least do that. So this is the nice thing about having the indication of what signal is on which pad, because I was able to catch it. I should probably also name this net here, but it's fine. All right. And then what we can do here, let's move this whole thing a little bit up, closer to the bucket. Should be good enough. I hope it will not collide. Like this, and like this. I put it a little bit in a random position here. So yeah, we will see if that will work out. There we go. Then we need the TVCC stuff. So yeah. That might be just a big connection plane that just connects this stuff together and we just drive it from here. That might be an option. Still need to figure out how we do this. Probably on the top side. Should do the job. Yeah, that looks good. Also, what's going on here? Why is this not connected to ground? Where did I screw up here? Oh, yeah. Pfft. Where's ground? People, where is ground? Who missed it? Who screwed up? Oh, God. Are you guys paying attention even? All right. I'm not reading the chat. Oh. Yeah. That's okay. It's my fault. All right. We need to start having audio call-ins through probably Discord. And yeah, we did that in the past. I should bring that back, so that if you feel like it, you can just jump into the Discord. I should make that happen for one of the upcoming streams. All right, so now they are there. Yeah, I'm not paying attention. All right, I need a really short break. I'll be right back. I will... Yeah. Where is it? There. All right, I'll be right back. All right. I'm back. Sorry about that. Yeah, I think that's a good idea with the bits and text-to-speech. That's a great idea. I will look into this, how to do that. That would be a great use of bits. Because highlights, I'm not sure I'm getting notifications for it. Although that might be a part of... I think I can do that. I think I can get them highlighted in the stream. The text, the highlights. Yeah. Have you double-checked R1 and R3? You mean in which sense? Let's see. R1 and R3. R5. So this will be R1 and R2 and R3. Yeah, so this should be correct because it's all, they are tied to ground, tied this way to ground. And then we have, yeah, so this should be fine. So these two are to ground, which is correct because ground is input this way and VCC is output this way. Yes, because it's an output, because it's clock and latch that goes to the gamepad. Yes, that is all correct. Yes, no, thank you. That's it's important to triple check for sure. Yeah, I see that I have the distances here are not consistent. Let's see, can I squeeze it together? I think I could. I can just pop it together. Let's do this. I didn't have to delete the central ones. Let's move this. Let's do that. Yep. And let's do that. I think that's good. That's a pretty good distribution there. Very good. So now we can... wow, what's going on here? There we go. Bump, 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 and bump, bump. Very nice. All right. Now we can. Now we'll figure out what to do with the vias. So this is a 2-layer PCB, and that will make things interesting. Come on. Like this. Like this. No. Come on, don't do that. There we go. That should... Do I want to do this? Make it suck itself to the... Yeah, let's do this. And then... Wow! I don't need to do that twice, yeah? There we go. And... ba-bump. Okay. So that should do this. Now we still need to 3.3 volts. Well, this will be fun because I need to get that via probably to the other side. Let's do... Come on. Oh, this way. Why is it 3. Do I have 3.3 volts on the power? This should be easy. Ground should be easy. that. There we go. Let's clean this up a little bit here. So that is looking pretty cool. I need to probably add an additional jet out. How do I do this? Because in theory, we just need 3.3 volts for the audio circuit. We need it for the audio circuit, and then we need it for this side of the circuit. So the best thing actually would be to put this jumper up here in the back, where we split this into 3.3 volts and the TVCC side. Yes, that's better. And then I can move this one to the top side, which is the TVCC bulk capacitance. No, that's not true. What are you talking about? Because this is 3.3 volts. This is just the... And otherwise we need to run the 5 volts up there. That is stupid. So yeah, let's just make the TVCC ground, the pour. The TVCC pour. And that would be TVCC. Flame Die, welcome to the stream. Thank you for the follow. And we want this. Minimum width. Thermal clearance is actually 2. And spoke width is 2.2? 0.1 or something? Yeah, I think that was it. Also, why am I on... What's going on here? That looks interesting. Wow, I have not drawn a polygon in a while, it seems. I was just copying them. Wow, I didn't realize it was drawing this outline so brightly. Huh, that's cool. Yeah, and we want it on the bottom side. Hello, what's going on here? I did put it on here. Yeah, there we go. Yeah, when I modify it, it doesn't do this. Like that. We actually don't need this that high. We need this. And we need this. Like that. We don't even need that. We just need it here. And it's like let's make it nice and even. And like that. That should do this. Wow! What did you do? Why did I move it? There we go. There we go. All right, you can show how it looks, page down. So this is the fill. It connects to the TVCC. We need the vias to connect the TVCC to the bottom side. So if we go here, I can go like that. I've been doing it for a long time. It's relative. That's very relative. I've been doing this for a little while. But I can't say I'm any kind of a graybeard or anything. There are people that have way more experience. It's like Jordi, I'm sure, has way more experience than I do making PCB design. And Yeah, I think my first board I laid out. Ooh, that's a good question. When did I make my first board? I think that's interesting now, because now I completely split it apart. Now, how do I connect this? Oh, this is stupid. So yeah, I do need to put this here somewhere. What do I do with the 5 volts then? I think I have to run the 5 volts on the top somehow. That will be interesting. Damn, that's annoying. I have only 2 layers here. It's really annoying. So my background is computer science, so I didn't do any of the. I didn't formally learn any of this. I learned all of it by watching others, learning from articles and people telling me that I'm stupid, doing it wrong. Yeah, it's the community is really awesome. It's like you learn a lot of stuff from other people and books, and yeah, it's a constant learning experience for sure. Yeah, this is annoying. I need the 3.3 volts to go as a plane here. I want the proper power here. And so I probably need to have this jumper around here, and then I have to figure out how to get 5 volts there. Probably running it behind so that I don't cut the plane apart, because the ground is also important, and this has to go on the top layer. Ah, it's so much easier with 4-layer boards. Oh man, so the question is, how lazy am I? Do I want to be super lazy and just add 2 layers for the ground and power? Ah, there's audio on the board. Ah. What? So, okay, straw poll. What do you think? 4 layers? Yeah, 4 layers. 4 layers. It's like, yeah, for the audio board, like the audio section also gives me a little bit of a headache here now, because it would probably be better if we have a 4-layer board. For that reason, for like having this a little bit quieter. What? Stop with it for. Fine, fine, okay, fine. No, yes, I'm lazy. Whatever. It's not worth my time. Let's go to 4 layers. It's fine. Yeah, they are both mixed. Whatever, it's fine. It's not that relevant. All right. All right, so this, first of all, let's copy the ground to... You came for the suffering! Well, this stream will take forever if I'm suffering here. Zero rich, that's great. Yeah. Yeah, 14-layer board. So actually, this is a fun thing. At some point, I reverse engineered a brushless motor controller from a reputable, like RC, like expensive remote control car motor controller. It was a pricey one. I took this thing apart and I was like, wait a second, this doesn't fully make sense. It turned out it was an 16-layer board or something crazy like that, because they used multiple layers to have enough copper in that board to run, what was it, like 40 amps? or something crazy like that. So multi-layer boards, very little signals, but like lots of amps. It makes sense, right? And yeah, you just basically layer it in there. It was just nuts. I was like, I grounded to the, on this side. 5-ounce copper, let's do it. Yeah, exactly. No, 5-ounce copper, or I've seen people ordering boards with like 3-ounce copper and multi-layer. They said it was super expensive, heavy as hell. Really hard to work with because you had so much copper. So reflowing this and like soldering parts to it, just any soldering iron, you just touch to it and it's cold. So pull out your flamethrower. Yeah, we need like heavy copper for 100 watt speakers. Yeah. Copper bus bars for audio. Yeah. Let's do it. I love it. It's great. Okay. Let's copy this. Let's move it to the inner layer here. So we have ground for this. We might want to actually remove the front ground fill because it tends to be annoying, but let's not do that immediately. Let's copy this one to the inner layer. Inner 2. And then we don't have the problem anymore with the ground fill here. So let me just make it visible here. Should I? Yeah, I should leave it as is. And just we can do some stitching probably to improve the situation. And this goes in here, and then we can draw a 3.3 volt one here for the rest of the board. And we should probably make this a little bit longer. Let's see. Seth Manu, thank you for following. Welcome to the stream. 20-ounce copper PCBs. Yes, yeah, I've seen that. This is great. Look at those boards. Yeah. This trace is holy crap. Oh, dear Cthulhu, what did you do? That's wonderful. Sure, there's another one. Let's see it. The DG key thing. Oh yeah, the bus bars. So yeah, this is pretty neat. These shunts. It's at some point, if you want to measure current and you need a shunt, you end up with essentially having a piece of very high quality piece of metal just attached to 2 pads that you measure current with. So yeah, it's great. Okay, so let's go back to some outline. It's in millimeters. Let's move this and make space. I don't think we need that much space, but we should still. Yeah. Does this look good? I think we have plenty of space this way. Some item number. All right, so like this. That should be good. And then we can put, now we do need a little bit more space because of all the capacitors. We probably need more space. Let's be generous here. Yeah, I will have to do the same reorganization. How there should be align and distribute. I thought there was a function to just disperse it. Yeah, whatever. Doesn't matter. U4 and U5, so these are the two channels. And then we need to move this like that, a little bit like that. Then we need the inductors. And we have two of them for the power supplies. Yeah, I will look into the schematic in a minute. Okay, so that's that. We still need the 3.3 volts, so let's create another one and try out the good looking tool here. I think that's should do the distance. 1, 2, yeah, 1, 2. We don't essentially need, we can also use the zone priorities. So with zone priorities, you can make a higher priority zone will push a lower priority zone out of the way. So if you have them on the same number, they will collide. They will just overlap and melt together. But if you have one that is higher priority than other, it will take precedence and make space for itself over another one. Okay, so we need 3.3 volts. Wait a second, we don't need to do that. We just need to add corner here. Add a corner here. We need two corners, 1 and 2. Zone outline in copper, and then create corner, and then zone outline. Create corner, and we have this like that. There we go. We need to go here. Yeah, I could. This is dumb. I should just make it a full zone. Yeah, let's do that. Let's do that to full zone. So essentially, so yeah, let me show you how the zones work. So when I do this, let's go to the inner layer. This is the power layer. And now if I do this, so essentially what will happen if I overlap this, you see they just overlap. It is not good. It's a problem, right? So I will remove this corner and remove this corner. Remove corner there. And then if I just make it the whole board size, and this is a problem, right? So now I go on the TVCC plane. This is the wrong one. This is the bottom one. I want the TVCC on layer 2, this one. Edit, and I increase the priority. Ba-bam! It created a trench here. So it pushed away the lower priority zone. So there you go. Thank you, Sylvain, for answering. Welcome, Teslaman. Yeah, as Sylvain said, it's a Pmod for an FPGA development board that will allow us to connect an SNES or NES or other vintage gamepad controllers to the Icebreaker FPGA, which is this guy, which is a product we make at 1-bit squared. Yeah, so that's it. Yeah, we need to add those vias. So I need to make a little bit more space here to add that via because I don't have enough space here. It's not nightly, it's stable. 515 I think. I didn't want to go to nightly yet. But I will do that soon, I'm pretty sure. Okay, so that's connected. I still need to connect ground. We don't really need to do that because the fills will actually connect it on the top, but I do still need those vias to have a good connection to the ground plane. So yeah, so this is an interesting thing that this will make George Lucamides happy. He had like a lengthy conversation how to show off things and to have good style, right? And good style is or because we're making it open source and because I'm doing it on stream, it is good to do the things beyond a reasonable level of to the right, like really OCD, because a lot of people will see it and see it as a reference. So George was making a good point there. And one of the things was capacitors, the coupling capacitors. And the best thing to do with the coupling capacitors is to have them connected to ground and power, and then feed the part from there. This is not really necessary in like lower frequency related stuff, but it's a good practice if you have the space for it. So yeah. Anyways, there are questions I see. They tagged RC. Oh, release candidate got tagged. Wow, nice. That's awesome. Yeah, so the pinout is essentially arbitrary. There are some standards for SPI and I2C bus, but no one really like adheres to them very much. Yeah. I feel that if you have a microcontroller where you cannot remap the GPIO, the Pmod standard breaks apart pretty quickly. Okay, so let's have a view here. Come on. So essentially, yeah, we still will need to get the audio stuff to the other side. I might do this actually on the other side of the board. I will run audio on the back of the boards so that I stay away from these noisy digital signals. It's really, so as Sylvain said, that's why we are putting the audio amplifiers, that's an exaggeration, the drivers near the connector so that we can run the 3.3 volt digital signal PDM or PWM, PDM in most cases, signal here, which is essentially digital, and then you have Schmidt triggers inside these driver chips. So they will clean up the signal on the other end. So it is not really a big problem if this is This is not so clean, but it's probably a good idea to be careful. So I will try to do that. I will run these on the back side of the board, like here, over there. Yeah, and we need to move this. This is not great. This is in my way. There we go. It's very warm today, turns out. Summer is coming. I'm starting to realize that in my room with all the lights on and stuff, it's becoming a little bit of an issue. Some of the stuff about decoupling, if I remember correctly. Yeah, so there's a, yeah, follow those links. What frequency can you even run the controllers at? Handbook of Black Magic. Yeah, this doesn't really matter. I'm far into the spec of the. So this is 2.2 millimeter trace space, which is well in spec of the PCB manufacturer. It's like that's not a. Oshpark will easily make those. So this is not even remotely something difficult to make for Oshpark. So yeah, it doesn't really matter. And this is why I have the push and shove, so that I can push the things and they will be fine. Crosstalk? This is irrelevant. This is not audio, this is digital. So this is for the gamepads, for the clock latch and the output from the gamepads, the data that comes out of it. It's crosstalk is not an issue in this case at all. But yeah, it's if I needed to be more careful than that, then I would TVCC. What are you doing? This is not TVCC. It should be ground. Yeah, ground. And TVCC ground, and I should probably push these a little bit further to make the ground connection. Yeah, I think I can do this, right? Yeah, I know. I can just copy the, copy? No, this is move. Control D, yeah, duplicate. Let's try to move these. That will be interesting. Will that work? Can I move that many? Yeah, thank you, KiCad. KiCad is awesome. Move. That should do it. Nice. It looks like, I don't know, bacon or something. Bacon strip. Move. Can I grab it? This will be... I'm not sure it is not... yeah, I think I should probably redo this. This is not... Let's move this here. And then let's do the TVCC on the back. I think I will just go this way. and do the 3. All right, so where were we? Cross-document clearance. Looks like you can only shift the controllers at some frequency. Shift the controllers at some frequency in the 1 kilohertz range. So yeah, it's okay. 100 kilohertz, that's DC. Yes, that's totally right. That's boring. So yeah, and we don't have. It has 33 ohm series resistors. Yes, the icebreaker does. Yeah, it's like also you have to consider that the signals will be going over pretty chunky amount of wire. So, yeah, the thing that we might want to do is add series resistance here. That is a possibility, but I don't think this is really necessary at this speeds. So yeah. Yeah, oh, the icebreaker has, yeah, that's correct. Good. So let's do this. Come on. What is the problem? Why can't I? Oh, haha. Old friend. Edit footprint. I still have to fix this. So I have those graphical copper connections. I did already talk about this before. And they collide essentially with the DRC. The DRC doesn't let me start a trace even. Ah, it's still not. It's still colliding. So I probably, if I go to 0.2, it will let me. Yeah, great. Annoying. All right. I have to probably move it a little bit more. What did I miss? I missed something. What happened? Ah, thank you for the follow, Tesla Man. I assume this is what happened here. Yeah, no worries. It's like, yeah, we are, things take a little bit time to get acquainted with, and questions are good. Questions are great, actually. I just want to also stay a little bit on topic because we want to get stuff also done, and I'm get screamed at later if I don't get stuff done. By likes of Sylvain, for example. It's like, I want to order the board. Finish it. It's hilarious. All right, so there we go. Let's do it at 0.2. And dump. That's connected. Thank you, KiCad. You did this. Yeah, we will I can probably add some kind of stitching or whatever. I don't know if I want to do that at the moment. But anyways, so now I think we should move on to the analog stuff. So page down, let's do... Oh, I can't cross it. Ah, yay. Okay, I have to do it on top then. It doesn't matter. But let's try to stay away from these. Hello, dem capacitors. Should I route you between? Like this? This is stupid. And I want it to be nice and routed on the back. But now I have the power there. Yeah, we might want to be able to get rid of the crosstalk here. So what we can do, I think, have at least a little bit of ground between these two, if it pours. How about doing this? Come on, you can do it. Almost. Almost. Like this? Does that make any sense? Is that useful in any shape or form? I don't know. It's probably a shrug, I would assume. Because we can do this here. Because we will have 20 megahertz on this. So these will go at some pace. So this is very different from these DC signals. These are like 100 kilohertz at max. So this is boring. But these audio outputs will be 20 megahertz or more, tens of megahertz. So yeah, let's add the ground wires here for these guys. And this shouldn't be 5 volts, it should be ground. Oh, because it's on the trace. Right. So let's add this. Ground. Can I squeeze in? Backside line. Yeah, I could also be completely crazy and run it all over the board. Oh, next challenge. PDM audio at 250 megahertz DDR. Yes. Yeah. Yeah, I don't think these. I would doubt that these buffers can do this. But yeah, that will be fun. Okay, so I added some ground stuff between these. Whatever. Now let's organize this stuff here. We are already almost out of time. It's almost 2 p.m. So I guess we will have another stream doing this. But yeah, let's try to organize this stuff and put at least the parts together where they belong. So this is the... Come on. 4, 5. Oh, they are in reverse order? That's interesting. Did I swap them? That's interesting. So 4 is left channel. 4 is left. And how does it go? I can, I think, visualize the signal here. I think I have to do this on both sides, which is a little bit weird. There. Okay, so this is audio L. Audio L. Audio L. Oh, it goes out to... So that's this guy, and... So right side... Okay, cool. So right side is lower. So I have it in the correct order. So this one should be on top, this one should be on the bottom. Geographically seen. So that's good. Deselect. Good, good, good. Then we need ferrite. Which ferrite? Come on, ferrite. Show yourself. Oh, we're still in the wrong mode. There we go. Ferrite. You're good. Move. So this is correct. This ferrite is good. Capacitor. Move. Then capacitor. That was wrong. This is the bottom one. This is the bottom one. This goes here. This one goes on top. You have to rethink. This is top. This is top. This is top. This is top. And this is top. Okay. And now let's do the bottom side. Bottom. Yep. Bottom. Yep. Bottom. Yep. Bottom. Move. Bottom. Move. Bottom, move, and bottom, move. Very good. All right. So now, this is power supply. That's the center. Something like that. I'm curious how this will work out. Oh, I probably will do something like this. And probably put it here above it for the power supply and feed it in here. Audio comes in here, that's fine, and this is the audio output path. You can do something like this, and then move. This is the downward path. Move like this. Oh, come on, come on, come on, come on. Move. Something like this. Yeah. We can now make it prettier. Like that. And then this goes like this. Should probably do this. Now, I think it has to be also in line to make it pretty. Like that. And then we have this fella. So that is our audio path. We still have this space, so I can move everything up. There we go. That's pretty. Yeah. There we go. All right. "45 rotation. So yeah, I changed that in my settings. So I Usually 45-degree rotation is not enabled. It rotates by 90. I think it's in the preferences here. Not hotkeys. It's in PCB new. There we go. Rotation angle. It's for you change it to 45 in here. So that's what I have set here. Yeah, you're welcome. That's nice. Yeah, we are all learning nice things. Yeah, I want this to be even. So I think I will do this so that it is all in this area. Then I can juk. It's not that it really matters, not at these frequencies at the end, like especially after it is already filtered. Okay, so now I want to, so do I want ground? Yeah, I want on the right side. So let's move this here. Let's swap the position of these two. There we go. And let's move this one. Ah, not 0. Yeah. Yeah, I'm looking forward to Spima having the fixes in his keyboard visualizer fix so that I can use his instead of this one. Will be nice. This is wrong. Let's do this. And then I can have via here, I can via here, and then I can have power supply here. That's good. And now I can, let's move this one. Like this, and then this one goes here. And this goes like this, correct? Yep. And we have this. And then we have this one. Like that. Wow, I can actually compress this. Like that. Something along these lines. There we go. Like that. Like that. Yep. Let's do this. $12.06, yes. Yeah. Ooj. Yeah, big chunkers. Yeah, I was hoping to be able to try out some of the foil capacitors, and they're massive chunkers. Chunk. Yeah. There we go. So that's our audio. Let's see. How much space do we need for this? Oh, this is actually taking up more space than I expected originally. So let's, that will fit just about here. Nice. Something like that. Yeah, I will put this there. Move. Let's get this out of the way. Caps are huge. 1206. Will you develop them yourselves? What is the question, Thanos? I'm not sure I got the question. Oh, if I will make... No, I will not etch the PCB myself, no. I'm not etching my own PCBs. I will order them from Oshpark. It's... Oshpark, it's like... I can wait a little bit for the boards to come back. And Oshpark just takes, what, a week and a half, maybe? So it's... in the meantime, I can work on something else. I have plenty of projects. I don't need to... I'm not... that time constraint that I needed tomorrow. So also etching this. Also, this is now a 4-layer board because I was lazy. So I'm not etching 4-layer boards. This will take me so much time. Ground rat's nest, if it is possible to disable it. Yeah, I think it might. I think there might be a way of disabling a certain rat's nest. I think you go on a signal. I think there is some option somewhere. So I usually reflow the boards. So I get a stencil and place the parts by hand, and then reflow the board in a reflow oven for prototypes too. I think that should be reasonable. It's still not too tight. Unless we want to put it just in the center here, behind the audio connector. But I don't think this is really necessary. Let's see. And then move. Like this, maybe like this. Let's give it some space. This should do the job. Okay. Okie dokes. This is looking good. I will extend the board here. This is interesting why this is outside of the boundaries. There we go, that's one. This is the edge cuts. Come on. All right, I should do the zone outlines. Zone outline, zone outline. Another zone. Yeah, so essentially I have not looked for that option to disable the ground rat's nest, because I usually have a ground pour, and this takes care of the issue that I see the ground net. There we go. There we go. Good, good, good. B. Wonderful. We can put the ground. Yeah, I should change my net, my grid. Now let's do the following. Maybe let's connect the... Oh, wow. Now the audio is reversed, right? Because it's left and right. So what should I do? We should just swap it on the connector here. That's the easiest. Because it doesn't matter, right? So let's swap it here. All right. Do it while we can. There we go. Perfect. Perfect. Like that. And we need this to go. How do we want to connect this? Maybe I will connect it like this. And then have the ground via here. Like this. And then put another one here. Ground. And then we need one here. And we need one here. And we need one here. And we need one here. Let's do it George style and place the vias before we do the routing. He was saying this is how he does it. He places power and ground vias first before he does routing, which is an interesting approach. Let's give it a try. Yeah, I did untangle it. I did untangle the audio signals. Doesn't everyone do that? Cross the signals, yeah. I might be missing some context, but that's all right. All right, then let's do this. And the important thing here, I think I should actually connect it like that. Although, then we get this to close. Put VS first, I meant. Yeah, I don't usually do that, or not often. These headphones are horrible. I need better headphones. Yeah, so I usually don't do that because I am space constraints usually. And so, yeah, I have not done that in the past. It doesn't mean it's the right thing. It seems to be a more common thing and making things easier. I end up adding the ground connection vias later, usually, which might be the wrong thing to do. Yeah. Alrighty, and bam. And then we need to connect this, and we need to connect power. Power connected. Now I would love to have some curved, an ability to do curved traces. That would be nice to like actually do the audio stuff in like nice organic manner. That would be really nice. Oh yeah, placing vias. Yeah, it is a fairly recent addition. It's really was annoying that we couldn't do that earlier. Yeah. Awesome. Luigi Frickers? Luigi Frickers, I guess. Thank you for the follow. Welcome to the stream. Sorry for butchering your name. I should just say welcome, welcome, as some other Twitch streamers do. Welcome, welcome. But yes, welcome to the stream. Thank you for the follow. Oh, why is it? Oh, this is no 0.3. We don't need that. Let's go back to point 2. Like this and like this. Whatever makes you happy, right? There's a weekend marathon of what's the painter called? Like, now blank on the name. It's like it's already late in the stream. My brain is starting to be a little bit frazzled. But yeah, it is a really good stream. I really recommend that. He has such mellow attitude. It's the best way. Bob Ross, yeah. There is a Bob Ross marathon every weekend on Twitch. There is a channel, Bob Ross. You should check it out. It's so soothing and so relaxing and wonderful. It's just the best. So guess what? We just routed the board. What is one unrouted? What is the one unrouted? Oh, there. That was the Bob Ross energy. The Bob Ross energy allowed us to route this board quickly and easily and without many issues. Bob Ross is not alive in the physical world, but still alive in the virtual sphere of people rerunning his videos on Twitch. Run DRC first. Yeah, of course. Yeah. Of course, we will run DRC. And it will explode. Kaboom! So what did we do? Oh yeah, so this is normal. And then we have the crossover. So courtyard, this is what I was talking about the courtyards. And yeah, this one we will ignore because these are the connectors in the right distance, but it has still a courtyard. He's alive in our hearts. Thank you, JKIV. That's exactly right. Bob Ross is alive in our hearts. Yeah, I remember watching him at night on German TV. It was one of the German public TV channels, and they were running Bob Ross non-stop on loop overnight. And yeah, this was a really good time watching that stuff at night on the couch and like falling asleep. Good old times. Let's edit this footprint and try to fix this. Is it possible? Let's do this like that. See if that fixes the DRC issue. It's just complaining about this copper pad that is connecting these two signals, which is intentional. Yeah, it's still complaining. Whatever, it's fine. It's it's close to graphic line. Yeah, you can't change that. If I change this to a thinner trace, then that would be possible. I also will increase this because I want it to. Anyways, there we go. Make it thicker because it's a power supply. Let's redo this. Let's rerun DRC. This will now explode in 2 places probably. Yep, yeah, there we go. It's exploding here, but that's fine. Now let's show the floodplains. So yeah, we have now this ground connecting these two, which is neat. Yeah, so the problem is there is not a good way in KiCad to do jumpers like this, where you have 2 nets and you want to connect them. 3D view, please. Yes, sir. There we go. I don't have the connector for the audio. I think Bob might have it. But yeah, this is how it looks. nice big chunkers for the audio. And now we have the connector for. Yeah, I will add signal legend on the back of the board. We can fix this, right? We can fix the labeling here, and we have the auxiliary 5 volts. Yeah, very cool. So yeah, we did it, which is nice. And I will clean this up off stream and send it off to Oshpark. That is very successful. We are 20 minutes beyond the usual runtime of the stream, but we did manage to do the layout. I could actually shorten it, probably by positioning those capacitors differently, but I'm not sure it is really worth it. Yeah, we can do, one thing I can definitely do is to fix the silkscreen here. Clock. This is latch. And, oh, that even fits. Wow. Yeah, so there's I for selecting a full trace. So this I think, selects this segment from pad to pad. And if I press U, it selects the full net. Let's see. No, oh, yeah, so let's see if I have one that has multiple connections here. So this is, do I have an example that would work? Yeah, there we go. That's a good example. So the TVCC, you see it's from pad to pad. If I press I, this selects actually the whole thing. Interesting. So there's a difference between U. U selects the segment between pad to pad, and I selects the complete net. That's what it was. So U is this, and I is the whole thing. There we go. Yeah, so yeah, the pad-to-pad selection is the U selection. There we go. Do I need to fix anything in here? Besides the silkscreen, I think we are good, and I will finalize that. Then I can place an order for all this stuff. This is becoming quite a decent 62mm board. Yeah, it's a long stick. I do believe that if I put some more effort into this, I'm pretty sure I could move the audio so that it is more horizontally aligned. So I could move audio in here and move this audio lower so that we could scoot this whole stuff into this area and then shorten the whole board. But I think for a prototype it will do, and we can futz around with it in the next revision or something. For now, we should be able to connect audio output and do prototyping with the pads, and also there is enough space for some legend in here as it is, and hopefully it will not cause too much interference between the signals. So yeah, cool. That was fun. I should add some 3D models before I post this on Twitter or something. Yeah, I already did. So you might have missed it. So here, this is connecting to, I call it pods. And the pods, I designed some pods already off stream. And just to review that again, there is an SL, so Molex SL connector pod. So that's Molex SL connector pod. And the other one is SNES connector pod, which is this one. So I did this, and this is the SNES connector pod. So I still need an NES connector pod, but to do that, I need a footprint for an NES connector, and it turns out and probably even a 3D model, but at least some dimensions, and I can't find any mechanical drawings of the NES connectors. I could not find any yet. So I guess I need to order some and measure them with calipers and make a footprint for it. Yeah, I know some people are getting some of those connectors for an NES. Yeah, but I could not find even existing KiCad footprints for NES connectors, which is very surprising. I did not expect that. Yeah, anyways, so that said, let's go back to the board that we did today. I think we will wrap it up here. I will do some cleaning and labeling, and I will push this to the GitHub repository. The GitHub repository, as always, can be found at Icebreaker. So GitHub, Icebreaker FPGA is the organization for the Icebreaker products and projects. And in there is an Icebreaker Pmod repository, which contains the design files for all possible Pmods. So a 7-segment driver Pmod, dip switch Pmod, 12-bit DVI, which is the HDMI thing, 24-bit DDR, 3-bit, and then 4-bit. So this is the predecessor to the 4-bit version, which has the intensity pin. Then we have the Gamepad and audio. That's what we are working on now. We have HyperRAM Pmod, so to add more RAM. And oh, you did find something. Cool. I will just look at that in a second. Then LED panel mini, like for a bunch of LED panels, which are these panels here, like this. Like a panel like this. I think I should do that for streams where it shows subscriptions and stuff on this. Something cool to integrate into Twitch. So I should do that at some point. But yeah, LED panel that you can connect. There are Pmods for this in several iterations. There's Quad HyperRAM that we made recently, and I ordered the panels I made the panels on stream. And a tri-state LED thing, which is a very useful device, where it's like you have red if it's positive, green if it is negative, and none of them light up when it is high impedance, the pin, which is very nice for debugging and testing of boards. So yeah, so a bunch of Pmods are in here. Also a lot of examples for the Icebreaker can be found here. For NMigen and Litex is an SOC. This is a stream also did. So yeah, you can find a lot of stuff in here. So check it out. Yeah, that said, I think we are at the end here. So I will say thank you everyone. Thank you everyone who joined the stream. Thank you for joining. Thank you for being here and supporting this. The subscriptions are always very welcome. If you want to check out the products we make, look down there. There is a link. 1bitsquared.com is our website. You can buy a bunch of the hardware that we are making here on the streams sooner or later. The Icebreaker is definitely there and available. We also have a German store, so if you are in Europe, you don't have to wait for a long time for deliveries or handle customs and whatnot. We really appreciate that. Icebreakers are back in stock in the German store. They just arrived like yesterday, I think, finally. And we have them restocked in Germany. The Crowd Supply website, as well as Mouser, are carrying a bunch of the Icebreaker stuff. Not everything we have in 1bitsquared, but at least some of the Icebreaker stuff. Mouser is in back order, but the package is on the way, and according to the tracking, it should be there on Monday. So it will be available very soon on Mouser again. Yeah, and so if you already have hardware and you still want to support what we are doing here, it's always appreciated, additional support. We have a Patreon, which you can also find down here. And you can get a shout out tier or chip in any money you want every month. It's very useful. It helps. It's making these streams also takes a lot of resources. It's like all the cameras and stuff and my time. So I appreciate your support, and I hope you liked it, and I hope you learned something interesting. And as always, I would like to thank Patreons that are in the shout-out tier and beyond, which is Edward Borden and Jordi Parky Rodriguez, Sid Price, Kelly, Tom Keddy, Drew Fustini, and Go Jimmy Pie, who is just there. So anyways, thank you so much, and thank you for your support, and I see you soon. And as always, if you have been, thank you for watching. Bye.